Everyone, this is 2003 June Regent geometry. Okay, so today we're going to finish part 4. That's the last question. Okay, number 35 here. I'm going to make big. That's better. Okay, to prove. Okay, over here, that is a quadrilateral, right? Yeah, that is not parallelogram, just the quadrilateral. And the AB congruent CD. These two sides are congruent, and they also are parallel. Okay, a diagonal AC the diagonal intersect EF at point G, and also these two sides are congruent. Okay, using this one, we're gonna prove G is the midpoint. This point is the midpoint of EF. So to prove right this is midpoint, we have to prove this side, the other side must be congruent, right? That's why the midpoint divide a segment into two congruent line segment. Okay, so we're gonna prove right the EG. First of all, our goal is right EZ congruent FG, right? Then G is what midpoint. So we're gonna prove this is the first. The easiest one is you already know the definition of parallelogram. Okay, you can make it short. I'm gonna give you the first method one. Better go this way, right? We need two column proofs, statement, and reasons. Okay. The first one, write the given, okay? Quadrilateral ABCD, quadrilateral ABCD, which is four sides, and AB congruent CD. Third one is AB parallel CD. 1, 2, 3, they are all given. From here 2 and 3, we can conclude the quadrilateral ABCD is a parallelogram, okay? If we know the property, okay. Over here, ABCD is a parallelogram, what is it? Parallelogram, okay? Black. What's the reason? The quadrilateral with a pair of congruent side parallel. Or you can say if one pair of, I'm going to this one, the formula, okay? If one pair of opposite side parallel and congruent, the quadrilateral is a parallelogram. That is the definition, right? You can use this one too. But now we know that A, B, C, D is a parallelogram. Okay. Now the problem of the parallelogram is what? Opposite side parallel and also congruent, right? Okay. Now you're gonna prove these two triangles are congruent, right? So the next one is what? AD congruent BC, right? Because that is a parallelogram. So right, the reason is what? Opposite side of parallelogram, or in a parallelogram, opposite side are congruent. Okay, EDBF. Okay, I forgot this. I'm gonna write down over here. ED congruent BF. Okay. So AD minus ED, that is congruent, and BC and minus BF, right? Equal quantity subtracted from the equal quantity that is still congruent, okay? The reason this one is subtraction, right? So the number AD minus ED is by EA, okay, or AE. AE congruent and CF. This is just substitution, right, over congruence. Just right, substitution is okay too. Congruence, okay. Now we got one side. The next one, we use an angle, right? Because the AE, this side, these two sides are parallel, and this is rather transverse, all right? So this angle and the other side angle. So this angle and the other side angle are alternate interior angle, right? So they are congruent. So before that, we have to say AD and parallel BC, right? The reason is in a parallelogram, opposite side are parallel. This parallel angle EAG, right? Angle EAG must be congruent angle FCG. FCG. The reason is what? It depends on your teachers. I'm gonna look like this, okay? A parallel line. Parallel lines. When parallel lines are cut by a transverse, alternate interior angles, so we got one angle already. This is the angle A, angle A. We need one more, right, to prove these two triangles congruent. Where is it? You can use a vertical angle, right? You can see that. That's the easiest way. The next one is angle AZE, angle AZE, and congruent angle CGF. This is number 10. The reason is what? Just simply vertical angles are congruent, right? Vertical angles are congruent. Okay. Or you can use what? Intersecting lines forms congruent vertical angles. You can use that reason, okay? Now we got another angle over here. What is it? Side angle or angle side. Okay, we already got everything. Okay, so triangle AEG. Triangle AEG is congruent triangle CGF. Okay, or CFG, right? The reason is angle side. Okay. The next one. This one you can use by anything, okay? It depends on teachers. Someone use by angle side, just angle side. That's it, okay? Okay, from here, corresponding side. Okay, EG and FG congruent, right? So EG congruent FG. Corresponding side of congruent triangle are congruent. You can use CP, CTC, right? Or you can explain this one. Congruent part of congruent triangle are congruent. I'm gonna write congruent part. The word is okay. Congruent part of the congruent triangle are congruent. Okay. So finally, from this, okay, congruent. So G is the midpoint, right? You can make decision. G is the midpoint. What's the reason? Midpoint divide a segment into two congruent parts. That's right, two congruent parts. That's why G is the midpoint. It's okay. Or if a point divide segment into two congruent segments, the point is the midpoint. You can use that too, but this is a formula, okay? You can use this one. Okay, the other way, method 2 is a little complicated, okay? Maybe first I'm going to show you a little about what different way to prove this one, okay? Explain. These two sides is congruent and parallel, right? Using this parallel, we're going to prove, okay, these two triangles are congruent. This triangle, the other triangle is congruent because one side and side, okay? And the other one, these two lines are parallel. When you make right, these two lines are parallel, and over here, these two angles is alternate interior angle, right? Okay, so this angle and the other side angles congruent. You got the 1A. So angle, side angle. Also, AC is reflexive, right? There's a common line segment which is reflexive. So this is another side. So using side angle side, these two triangles are congruent. Okay, using this congruent opposite side, this is corresponding side, okay? AD congruent BC, okay? AD and congruent BC, okay? After that, these two sides are congruent. This also congruent, so that is a parallelogram, okay? So you can continue from here, right? But that is a little more complicated. Okay, if you know the way, this one, to be parallelogram. Quadrilateral to be parallelogram, what is that? Both opposite side are congruent, or both opposite sides are parallel. Third one is one pair of opposite side are both parallel and congruent. That is a parallelogram. Okay, so we use this third property. Okay, okay. That is number 35. Okay, this geometry proof is very important. Okay, so you need a little more practice where understand 100% about these questions. Okay, okay. Thank you so much. Maybe I'll see you next one is 2003 January test. Okay, thank you so much for joining the class.